Hello and welcome to my video presentation on image processing, my final year project for my University of Greenwich project for the Bsc Computing. Now, as you can see, there's several windows around me, all of which host some really important information. To the left, you can see the detection screen, which shows how much of it is detected and how much is not detected. It's in a binary image. To the right, you can see the exact same thing again, except it's just edge detection instead. Slightly different. In the bottom right hand corner, you'll see the console window. The console window contains basic information. The 5000 for the point X and point Y simply means nothing's detected. It's currently in default to left view when nothing's there at all. And the -1 is simply a readout to say that there's no iteration, there's only been one iteration of the entire program so far. Now, in the bottom left hand corner, we have the sliders. It's on a HSV sliding scale, so it's hue, saturation, and value. That allows us to switch between, very similar to RGB, what colours we're looking for in the actual image. Now we have a brightness and alpha adjuster, so I'll display them now. The alpha could be turned off or turned on, depending on the situation. Of course, this can be reset back to normal. This allows better protection in systems where we need to lower the light level a certain way without impacting on image quality. With the brightness, we can completely change the image quickly, make it darker, or make it lighter. Now, this in itself, pretty simple. The idea is, in a situation with lots of excess light, we can drop the brightness down and get a much clearer image. With the other situations, we get the brightness up and get a much clearer image again. Now, what I'm going to show you is, I'm going to grab a ball. Okay, so I've got my green ball here, and we'll just adjust the hue, saturation and value until it matches the colour. The idea is we want to keep the ball as white as possible, while turning all the other elements black. So it requires a little bit of filling around at the side here. When that's done, we're left with our clear detection image. There'll be some spots of noise, that's really normal, but it shows how versatile the mechanism is for detecting using colour-based, simply because the colour-basing is only detecting the object itself, not the noise. You'll see there's numbers generated in the first part, which is saying the centre point and location of the object. The same thing is up in the top left-hand corner up here, and they're just being used exactly the same thing. Instead, the tracking object comes up at the top left-hand corner, so you can just see that the object's being tracked. Now, if you look at the console output here, we have the different states. Now, the positions again are being pushed out to the console, and we also have the sensor being registered where the ball is. If we move this, that changes the top, changes to the right, the left, and the bottom. So as you can see, as that moves around, we're constantly getting changed location as to where the ball is on the screen. That shows that it's working, and it gives a brilliant input for any sort of feeding device, that an motion bot or something that wants to follow a ball can easily change that to an output to move left and move right. So that's always useful. The program counters iterating as we go along as to how many times it's moved between the two, as you can see, a little bit of testing with it. If you throw it around, we'll notice it gets quite a good detection speed. It is never designed for speed, it was always designed to be done at slow speeds, yet despite this it still does a really good detection value at high speeds, so I'm actually really pleased with it. As you can see, working fine. Now what I'm really going to do is switch up a little bit. Now it can't detect multiple objects, but what it can do is it can detect a different object if we give it a different set of attributes. So here's my blue ball. I'm going to do exactly the same thing I did with the green ball, but this time we're hoping we get this one come up and not a green ball. So we have let's adjust the sliders. Now blue is always a funny one because that goes in the middle somewhere, but a little bit of tailoring, that should go down quite well. And there we go. One ball detected. As you can see, it no longer detects the old ball. Got a bit of noise there for a second. That's quite normal. They're very similar in colours to computers. But the noise goes off really quickly. As you can see, move this around. It no longer cares about this. It's only interested in the one we've set the attributes to. So that's fine. Now, as we can see, that's working fine and really working well. The idea now is to think about what sort of future implications this could have. Now, for me personally, I was thinking the best thing we can do is probably something along the lines of aerial drones or movable vehicles, security systems, entertainment and leisure, anything that allows the inputs from the console window to be translated back into something we as people can use, either from a computer standpoint or any other standpoint from there. And it really fits in the whole premise of image processing, which is to take something from a computer's point of view, transfer it into an image that can be used by a computer or a human being, and actually provide some real world data. And yeah, that's my project overall. I'm really pleased with the results of it. It's done really well, And yeah, thank you for watching.